Okay, good day once again, and we are about to proceed to our first topic, which is the graphical projection drawings. So this is an illustration of graphical drawings family tree. Okay, so the graphical drawings are divided into two families. These are the parallel projection drawings and the uh, perspective projection drawings. So in this module, we are going to focus on parallel projection drawings. So a parallel projection drawings is a projection of object in a three-dimensional space in a fixed plane known as the projection plane or image plane, where the rays known as the lines of sight or projection lines are parallel, okay, uh, to each other. So it is a basic tool in descriptive geometry. The projection is called what we call the orthographic if the rays are perpendicular or orthogonal to the image plane, and oblique or skew if they are not. So in the graphic and arts, the perspective is another sort of projection drawing. So a perspective drawing is an approximate representation of an image as perceived by the eye, usually in a flat surface. The most distinguishing characteristic of perspective are the object, okay, appearing smaller as their distance from the observer increases, as they are subject to foreshortening, which means that the dimensions of an object along the line of sight appears shorter, okay, than the dimensions across the line. So this is it, okay, or the line of sight. So orthographic projection is a type of parallel projection where the projection of rays are perpendicular to the projection plane, and it is the projection type of choice for all architectural and engineering working drawings. So the term primary view is also used, which includes the plans, the elevations, the sections. So in multi-view drawings, the drawing is, or the pictures is up to 6 pictures of an object. Okay, with each projection plane perpendicular to one of the coordinate axes. So, so let's distinguish. Okay, so the orthographic projections. Okay, so we have the first angle projection. Okay, the first angle projection is one of the ways of representing three-dimensional object with respect to two-dimension, which is commonly used in European countries and most of the world, except the United States, its colony, and Australia. For getting orthographic views from a 3D object, we divide the plane into 4 quadrants. Okay, so you remember your analytic geometry. So this is the first quadrant. Okay, so the object is placed in the first quadrant for the angle projection. Okay, so when you project the faces, you see this line. Okay, this one and this one. Okay. To get the third angle projection, the object is placed in the third quadrant. Okay. So, so the object is placed below and behind the viewing planes, meaning the plane of projection is between the observer and the object. So United States, Australia, as well as the Philippines uses the third angle projection method as their default drawing system. So in the first angle projection method, the orthographic view is projected on a plane beyond the object, and the observer is on the left side of the object and projects the side view on a plane beyond the object. Okay, so meaning the right side view is projected to the left of the front view, and the top view is projected on the bottom of the front view. So while in the third angle projection, the observer is on the right side of the object, and the orthographic view is projected on a plane located on the viewpoint of the object. Okay, so the right view is projected. Okay, the right view is projected on the right side of the front view. Okay, and the top view is projected, okay, above the front view. So now you are familiar with orthographic projection. So the application depends on the convention, where the drawing is, no system. Okay, so Europe and its colony are familiar with first angle projection, while the US, its colony like the Philippines, Australia, uses third angle projection. So we have this axonometric projection. So axonometric projection, or drawings, is a type of orthographic projection used for creating pictorial drawings of an object, where the object is rotated around one or more of its axis to reveal multiple sides. So the three types of axonometric projection are: one is the isometric projection, the dimetric projection, and the trimetric projection. So depending on the exact angle at which the view deviates from the orthogonal, typically in axonometric drawing, as in other types of pictorial drawings, one axis is one axis of space is shown to be vertical. Okay, so this is the vertical. Okay, so let's focus on isometric projection. Okay, so in isometric projection, this is the most commonly used form of axonometric projection in architectural and engineering drawing. Okay, so the direction of the viewing is such that the three axes of space appear equally foreshortened. Okay, so this, you have your equal angle. Okay, so the views are foreshortened by equal angle, which is commonly, the common angle is 120 degrees between them. Okay, as the distortion caused by this no no the foreshortening of the object is uniform. Okay, all through the three sides, at least three sides. Okay. Okay, the proportionality, okay, between the lens is preserved, and the axes share a common scale. Okay, so all of the sides shares a common scale. Okay, yeah. Okay, that can be directly measured from the drawing. Okay, so another advantage of isometric drawing is that the 120 angles are easily constructed using only a compass and a straight edge. Okay, and you have your 30 by 60 triangle. Okay, so in the dimetric, both in dimetric and trimetric drawings, okay, the sides, okay, the sides have dimensional approximations only. Okay, so the term isometric comes from the Greek word meaning equal measure. So reflecting that the scale along each axis of the projection is the same, unlike some other form of graphical projection such as your dimetric and trimetric, as well as perspective. Isometric projection, as we know it, has been for centuries, until it was formalized and created a rule on how to draw a isometric drawing by Professor William Farish in the 19th century in France. Okay, and it has been an invaluable tool for architects and engineers, designers to use in their work. Okay, so an isometric view of an object can be obtained by choosing the viewing direction, such as the angle between the projection of the x, y, and z axis are always 120 degrees. So when showing a certain architectural volume at scale, we can utilize isometric drawing. In other ways, it would be imperceptible from conventional or manufactured viewpoints. I recommend that you begin by creating a two-dimensional technical drawings for your volumes, whether they are triple projections. Okay, you draw the front, the top, and the side views. Okay, single facades or a facade and a plan, if that is architectural. So in this manner, you can begin to comprehend what you're creating and see a way better the design or idea. Following that, it is natural to switch to axonometric mode to examine how the prior drawing seem in three dimensions. Okay, by hopping from one drawing to the next, you'll get entirely a new concept, and your design will gain depth. Okay. Additionally, you can use isometric sketch as an exploding uh, axonometric to produce an integral final conceptual piece in architecture and interior design. Okay. So this is an example, okay, of isometric exploded drawing. So it gives you the every details, the information, how things are interrelated and interconnected to each other. So what's the minimum scale when drawing an isometric drawing? So unless you are doing it on a computer-aided design software and you're going to print it on a preferred scale, manually drawn isometric drawing should be at a scale of 1 is to 100, the minimum. Okay, because it is the most approachable and and can be even drawn on a small format paper like an A4. So there's no shortcut for this. I have a couple of videos I would like to share with you that will get you understand isometric perspective at a whole new level. Okay, take care and draw nicely. So please, okay, complete your exercises for this module.